I think the key things I think they wanted to talk about is Taiwan and its position in this whole global AI ecosystem, and then we'll talk a little bit about sort of how it will sort of evolve in this new environment of sort of geopolitical and security pressures.
Yeah.
And then lots of the environmental resources, labor resources, the shortages, and how does Taiwan step up to the plate in that? And then where's the biggest opportunity in the value chain for Taiwan? I mean, Jensen mentioned this morning in the keynote that Taiwan's GDP is expected to grow nearly 10%. So is that all because of NVIDIA and TSMC? So we want to understand like maybe where that wider growth is going to come for Taiwan.
Yeah, okay. First of all, when President Lai invited me to National Science and Technology Council, my first job was to have the science and technology policy approved by President Lai. Yes. And I said the 4 pillars for semiconductors and AI in our government. The 4 pillars are, first of all, we need to continue to maintain our competence in manufacturing technologies, advanced manufacturing technologies, not just semiconductors, but also the AI servers and so on. In order to do that, we need to continue to invest in R&D, not just the government, but also encourage our private sectors to continue to invest. That's the first we need to do. And the second pillar is that in order to maintain the leading edge, we need to strengthen our international collaboration. Right. Because we can't do this close in our country by doing research by ourselves. It's impossible.
Well, NTU is good, but I think we need those collaborations as well. Yes.
We need to collaborate globally,
yes.
Especially the democratic free countries. We need to protect our technologies as well. So we strengthen the relationship with the US, with European countries, with Japan, and so on. Because during the early research stage, we encourage our professors, scholars to go out, to approach different partners in the world so that we can improve ourselves. And after the international collaboration in scientific research, we can absorb the results, get back the leading results from international societies. Then we need to work on developing our manufacturing technology at home. So by doing so, we can also benefit the international partners in the technology development stage. We need to collaborate with companies worldwide in equipment development, new equipment development, new materials and chemicals, and so many things we need to work with all over the world. Yes. So in addition to academia collaboration, we need to have industrial collaboration to have friends all over the world. That's the second that we need to maintain or strengthen. And the third is that after we have established the economic strength in manufacturing, we need to also benefit our societies in other application areas. So we talked about AI robotics, we talked about space industry, we talked about autonomous vehicles or EVs or drones and all such kinds of autonomous maybe in a general term robotics in the future.
Yes.
That's our very important direction at this moment. And in order to make it usable by all industries, not just the manufacturing industry, but also service industries as well. Healthcare, transportation, education, agriculture, and so on. We need to improve the traditional industries. So we are also inviting international partners which have been very innovative in applications, like the US, Europe, Japan, and so on, inviting them to invest in Taiwan, collaborate with us. With our manufacturing leading edge, we can collaborate with them, and Taiwan will develop ourselves as a market for them.
Yes.
Not just.
It's a circular
right
approach.
In this approach, we can be stronger in terms of relationship with all these international partners. And then the final one, the fourth one, is that we are responsible country. We look at this net zero objective is very important for us. So when we are developing our industries in Taiwan, we also look at how to make the manufacturing cleaner in the future. We're looking at energy efficiency issues. So in terms of semiconductor and AI industry development, we are also talking about we need to invest more in power electronics semiconductors.
Right.
Yeah, and so compound semiconductor also is one of our investment at this moment. That also includes silicon photonics. When we talk about silicon photonics, we're not just talking about manufacturing the products, devices for data centers. We are talking about all photonic networks in the future, so that when we including the computing power, equipments for computing power, but also for network equipments as well, and also in the future for edge application, endpoint application devices, or edge computing servers and so on. But in between the network is very important. We are visioning that in the future we will replace copper with optical fiber to drastically reduce power consumption during networking, the data transmission, and then we have already demonstrated the proof of the concept in late April in Thailand. Jointly, I'm asking Chunghwa Telecom and NTT from Japan working together, developing the all photonic, all optical switches, and data center interconnect infrastructures and so on. And it's been proven, the concept.
One interesting thing you've just said, I mean, you've talked about a lot of different technologies and sort of materials very holistically, but do you think, for example, Taiwan's expertise in manufacturing is going to be a key to translating scalability of silicon photonic manufacturing? Because I think that's where one of the bottlenecks has been in the past.
That's very important, yes. I do think that the reason that all these international partners would like to collaborate with Taiwan is that currently we have been working on silicon photonics in the past few years, and we are certain that to enable this kind of future all photonic network, semiconductor silicon photonics platform is very important, and we know that TSMC is leading at this moment in the domain that we can now is in mass production already. The devices for data center computing equipment. However, that's not good enough. We are setting up an entire ecosystem for not just the data center equipment, but also, as I mentioned, the network equipments, the edge computing servers and endpoint devices, even robots in the future, which is moving vehicles, and all this needs a second platform, maybe a third platform, for less expensive, using more mature technologies, not just the advanced technology.
Yes.
For photonic.
Exactly. But one of the things most refreshing about this conversation is you haven't really mentioned AI, but it's all the technologies which are impacting the development of AI, which is actually quite good, because otherwise a lot of people are using, and including keynote speeches we hear now, marketing products for AI.
Right. When we talk about AI, from National Science and Technology Council, we set some priorities. The first is silicon photonics, the core technology. But people wonder why silicon photonics is related to AI, because, as I mentioned, from silicon photonics, we can invite all partners to work on these very important equipment for all photonic networks to enable real future applications for ordinary people, for different kinds of service industries as well, to serve all areas. That's the beginning. Without silicon photonics, it's very difficult to do that in the future.
Right.
And then we are also talking about quantum computing, but I'm talking about high performance quantum computing. Quantum computing will serve as a very new and important computing power to complement current computing structures, which includes CPUs, GPUs, and all these ASICs and so on.
Yes.
In the future, there are certain problems that can be solved by quantum, but quantum cannot do all the applications by itself. We cannot do that. So with the collaboration of these international quantum giants, if they can collaborate with Taiwan based on our semiconductor strength, it'll be easier for us combine together to help commercialize future quantum computation.
Well, I mean,
maybe.
It sounds like you've sent some really strong messages: silicon photonics, quantum, partnering, the energy.
Yes.
What's exciting you most at the moment? I'd like to just, for your job and for the industry.
Making me most excited is that we didn't think about by manufacturing hardware for all over the world, for all these very innovative customers, our customers in the world, would be getting so excited today that we can really enable, playing as a key role to enable innovation which we can't think about 10 years ago. For example, the ChatGPT, the AI agents, and so many different things. Without the semiconductor manufactured by Taiwan, it's quite impossible that we can benefit from this. So knowing that Taiwan can make all so many innovative ideas come true, we do get excited, and we are really willing to play the role to enable future generations of the innovative ideas. So we invite all these international partners to Taiwan. For example, during this week, Computex, we are making friends and really would like to play the role, continue to play the role in the future. But not just as a manufacturer, we would also like to collaborate with new applications. Yeah.
Well, that seems like you're also saying, don't worry too much about the geopolitical and security pressures.
No, I don't.
I think it's important to collaborate.
It's very important for us to collaborate to make us safe.
Yeah.
So when we continue to do so, I'm not worried about we will be isolated from the rest of the world. The challenges, we do have so many challenges: human resources, electricity, power, and water, and we also need to make sure that the environment will be protected. Maybe will be better in the future. So I have set a goal that when we develop new science parks, or even modify the current science parks, we need to maintain the ecology, not just to maintain, but make it better in the future, to help all the species to maintain and maybe getting the endangered species to come back. All these kind of things are our goal. And for the scarcity of all the resources, we are also, during the way that we find partners, collaborators, we are also willing to invest in other countries to help manufacturing. Today we have collaborated with the U.S. government and the Japanese government and German government. We are willing to invest in all these different areas where they need advanced manufacturing for semiconductors, for AI servers, and so on. So that will reduce our burden for resource import from other parts of the world, and also make the relationship stronger in the future. So we would like to share not just the manufacturing capability, but also share our market as well, domestic market, because Taiwan's economy is growing. We currently, I think we are number 21 last year, based on the numbers in the book, 21st largest economy in the world today. So Taiwan is not a small market anymore. We would also like to share our market for international partners, and we help each other. And also, because of the lack of electricity, we are looking for partners, maybe Philippines, Japan, or other countries willing to share the resource with us and help each other. Yeah. See, viewpoint, we also develop science parks and operate science parks. So from day one, it was called National Science Council without technology, but from day one, actually technology was inside National Science Council. So when we develop the science parks, we invite companies to move into the park. We ask them to do research, to do R&D, and ask them to collaborate with the academia. And the system, because the same National Science Council sponsoring the industrial R&D, and also we sponsor the academia research. It's very easy for us to match them. Yes, and that's much more efficient for what you have mentioned, from lab to fab, and over the several decades, we found this system very efficient, and semiconductor industry day one was the mainstream in science park. That is why it's been so successful at this moment. When we look back, this system is very important. And one unique point is that in Taiwan, the government is responsible for developing the parks instead of leaving it to the private sectors, which is very key success point. And we also set up a single contact window for all the companies to solve any problems that they need to go to different government departments. But there's only one single window. We solve all the problems for them. And today we think that the return is very high. The government investment first to develop the parks. We borrow money. Today we still borrow money from the banks, and for the next 10-20 years we get the return very, very high. It's quite a good business for the government to do. Very efficient and profitable for us. So the government is very happy to develop more
Well,
science parks.
Yeah. Well, Minister Wu, thank you very much.
Thank you. Thank you for your time.